Hi, everyone. Welcome to Healthy Air. Joining me today is Dr. Marwa Zaatari, Chief Science Officer at ZINE Partners. Marwa, welcome to Healthy Air.
Thank you for having me.
So I want to provide our listeners with a brief background on Dr. Zaatari to provide context for our conversation. Dr. Marwa Zaatari is Chief Science Officer at ZINE Partners and co-chair of enVerid Systems Advisory Board. She leads the research and development of air as a service around heat exchanger coils, ventilation, filtration, and indoor air quality measurements. Her work continues to advance building science methods in assessing performance-based procedures to design and operate buildings to optimize energy and people efficiency. Dr. Zaatari has extensive experience in identifying and quantifying the sources, fate, and transport of indoor air pollutants, building energy and environmental management, assessing performance-based procedures of HVAC ventilation and air cleaning, and developing and applying models for energy efficiency, indoor air quality, exposure assessment, and economic impacts of indoor air pollution. Dr. Zaatari earned a Ph.D. in architectural and environmental engineering from the University of Texas at Austin, with a focus on the built environment, and a master's degree in engineering management from the American University of Beirut, Lebanon, with a focus on energy management. Dr. Zaatari is a board member at the U.S. Green Buildings Council, USGBC, and is an ASHRAE Distinguished Lecturer and a member of several ASHRAE committees, including a member of the ASHRAE Epidemic Task Force and voting member of Standard 62.1. All right, well, quite an impressive background, Marwa. Thank you so much for joining us. Please tell us how you got your start in the world of HVAC and indoor air quality in your path to your current role at ZINE Partners.
Thank you so much for having me. And I always knew that I wanted to be in this field. Since I was a child, actually, I was really fascinated by the field of energy in general. Just a little bit of a story about me. I'm originally from Lebanon. I was born and raised in a very, very small village in the south of Lebanon. And I remember throughout all the years growing up, all my years of school, there was something that always bugged me, is we only had electricity for 12 hours per day. Wow. So meaning that I needed to shower on a schedule, study on a schedule, use the washing machine on a schedule, etc. And back then I was like more on the naive side, that I thought, oh, it's all about energy conservation, that if we conserve energy, then we can have full-time electricity. So I set my goal on studying like a field related to energy. In Lebanon, we didn't have HVAC, so I didn't grow up with a house with HVAC. If it's hot, you know, so it is what it is. So it was a little bit hard to go get an engineering degree, you know, as a girl from the south of Lebanon, to go to the city and do engineering. And actually, I did my mechanical engineering degree without telling my parents. I only told them after I finished, because they wanted me to go to the field of, you know, teaching and literature, stuff like that. So I did my engineering focus on energy and controls, and then my master's on engineering management, specifically energy management. And then I learned is that, you know, energy efficiency is great, but what about indoor air quality? I remember reading an article back then when I was in Lebanon. I read a lot of books because we didn't have like good internet to download things. So it was more on the book side. And then I was lucky to come to the United States, to the University of Texas at Austin. And I was at the right time, because I joined this amazing program. It's one of the best in the United States about the indoor air quality in the built environment. And I was lucky to find funding specifically about energy and indoor air quality in the built environment. So this is how I started my journey, specifically about energy and indoor air quality and how to balance both. I worked all my profession in trying to bridge between academia and science, and between the practicality and feasibility and, you know, cost reduction. I always see, you know, science always say, you know, we need to do more research, it ends. And in practice, there is a lot of disparity of what the science say. So I try during my profession to bridge this gap. So I knew that I wanted to go to industry to do this specific mission.
That's remarkable. What a great story. So prior to your current role, I'm kind of skipping forward a little bit here, but prior to your current role at Design Partners, you were VP of Building Solutions at enVerid, and you continue to serve as the co-chair of enVerid's advisory board. Can you share a bit about enVerid in your work there?
Yeah, I kind of joined enVerid since the beginning, and I stayed with them for 6 years and a half. And it was quite a very good experience for me because we were a small team focused on innovation, but this small team had very deep expertise in things that are not per se related. So we had expertise in chemistry, material engineering, sensors, controls, HVAC design, operation, and project management. So it was really cool to be in a company small, so you get to do and learn about the different fields and how they interact together. And also enVerid work is more on the innovative side. So they're always basically where in the mission and vision to use or produce innovative technologies to bridge between energy efficiency and indoor air quality. So I learned a lot during my journey, and I'm still learning, and developed a lot of different tools to do calculations and a lot of different measurement and verification protocols, lab standards, testing, etc. Yeah, so that's a little bit about enVerid.
Okay, well, 6 months ago, you launched your current company, Design Partners, which is a nationwide boutique design firm dedicated to delivering performance-based solutions that achieve clients' indoor air quality and energy efficiency goals. So you posted on LinkedIn a pretty heartfelt announcement when you founded Design Partners, and I'm going to read a part of it. While the safer choice during COVID would have been to stay put in a familiar job, I've resigned myself to do the opposite. It is at the worst of times when we remember what matters the most to us. This is why I wanted to refocus my efforts on what got me into the environmental field, and specifically indoor air quality. It would be great if you could elaborate on that. What prompted you to go off on your own, and what is the mission and focus of Design Partners?
Yeah, so from the beginning of this pandemic, I was doing volunteering work, and even before in standards, but I accelerated my volunteering work from the beginning of this pandemic. But I remember this one day where we used to live in Boston, and we used to live in this historic home, and it had like 3 floors. And we never used the 3rd floor until the pandemic hit. My son was at home, so I needed like a less noisy place to work and all of that. So I remember I opened the 3rd floor, it had nothing. I only can hear my echo. I set up my desk, my laptop and all of that. And I remember I sat down, it was so silent. And I just could not get myself to work in the same work that I did before COVID. So I knew that I wanted to do volunteering full time. And I knew that I want to focus on like every single solution that is on the market, from the ventilation, energy recovery, every single solution about filtration, air cleaning, sensors, etc. So this is how I wrote this, post on LinkedIn, and this is how I started. And most of the work that I did so far is volunteering, and mostly is for schools. And I got so many friends, so many mom friends that ask me questions about things related to the pandemic, schools, etc. So I have this large network of moms that we share, all the struggles to be working during a pandemic, having kids, and trying, to really like make the world a better place in our tiny little universe of indoor air quality in schools. Mm-hmm. So, and in the context of Design Partners, the mission here is to try to bring performance-based approaches to things that we are familiar with. Mm-hmm. So first we focus on the basics that worked before COVID, that we know they work during COVID and will work even beyond COVID, but we need to make them better in a performance-based approach. And then innovation will come because there are a lot of different companies that are working on new solutions or new technologies or new processes, strategies, tools. So the goal is to try to encompass that in all solutions for basically clients that basically focus on existing buildings in operation.
So you mentioned this in some of your previous comments. You've been kind of straddling the commercial industry world and then the deep kind of technical scientific world, both in terms of your own academic background, but also your involvement in some very influential organizations within the built environment. And two specifically, USGBC and ASHRAE, you're very involved, you're in leadership roles. Both of those organizations are playing a big role at the kind of convergence of the two issues that you focused on, both the kind of energy efficiency, sustainability side of buildings, and then the health and safety and indoor air quality. What motivated you to become so active in USGBC and ASHRAE, and what has been your focus in each of those organizations?
Yeah, so for ASHRAE, I was actually funded by ASHRAE to do my PhD. So I don't know if it's still correct, but they give the largest sum of money to the research that I was doing, or I was able to do because of this funding. And I used, when doing my PhD, I used to present to the ASHRAE Standard 62.1 committee. So I felt like, and like an attachment, and more important, like a huge deal of gratitude that I have to give back and, help young engineers and also help to improve the standard. So a big portion of my PhD is that there was like few loopholes in the standard that I want to help to fix by measurements, modeling, and then close the loop by actually improving the standard. So I learned the word of ASHRAE from my PhD, and I found that I have a lot of passion specifically to make an impact by changing standards for the better. So I really like this, and it's a little bit emotional for me, but a big portion of me being in the US is basically ability to make a change, which I didn't have this opportunity, where I came from. And I know it sounds like a little bit small, but making a change in a standard is impactful, especially standard 60.1. It's like the standard that bans smoking into buildings, So from this standard, it goes to, the local city and state codes, and it gets implemented in all the green building certification, etc. So though like it can be a very small change, but it has a big impact. And for USGBC, basically, the standard is like more a minimum standard and more a design standard. Well, USGBC was able to have like, I call it ventilation on steroids. So to take it to the next step, to say, maybe we can push the boundaries a little bit. Maybe we can have more requirement. Maybe we can, not only, sort of design, install, and forget. We can continue one more step and ask for testing, maybe a yearly testing. So it was really nice to see that, maybe we can do more. And the nice thing is that they always ask for feedback from project teams that we receive, and we take the feedback and we try to implement it in a more feasible, practical way, basically.
Yeah, well, and I think that within the built environment and building engineers and so forth, I think there's a great appreciation of how influential a standard change is. I think that to many people, they don't understand how it really sets the rules of the game for spaces that people are occupying on an everyday basis. So totally agree on that. Your research and career has been, as I mentioned, kind of at the intersection of one of the predominant sets of issues within the built environment today, which is sustainability, health and safety, and then the kind of economic aspect of those two things. And in some ways they're aligned, in some ways they're tensions. How is this expertise and your kind of vantage point, given your background, informed how you're experiencing the pandemic, and particularly around the indoor air quality challenges that we're currently facing? In some cases, many people have said that these challenges have been around for a long time, and now the pandemic is just kind of blowing the lid off of them, and we're dealing with much more urgent and deadly type of risk. But now it's very much in the spotlight and more in the mainstream of people being aware of these. So how has your background helped you process what's going on right now, and then also where we're going.
Yeah, I mean, you're right about the mainstream, because when would I ever think that I'm gonna hear the word MERV from a governor, or ventilation to be used multiple times to win like a presidential debate? And maybe it's only in my head, but it played a role. And like, when would people want to get a CO2 sensor to a restaurant or a classroom, or ask, you know, what is a MERV level? What did you do about ventilation or opening windows? You know, so these all, if I were to say this, which I know it's not like, you know, very politically correct to say it, but if any silver lining of the pandemic is this, like the sudden awakening of the indoor air quality issues. And as you know, it's not only about the pandemic. Like I always say this, there's a big gap between disease prevention and having a healthy buildings, especially when it comes to schools or financial institution or office. Like, we want to be productive, high ability, cognitive performance, and also a lot of different like odors, basically bioaffluents, and like the flu season, etc. Like, we want to be in a healthy space, but it took the pandemic, a very tangible threat, for us to have this discussion. So my work in education and training is about like ventilation, filtration, air cleaning, airflow distribution, the code, what we need to get into our building to be able to occupy it, and all of that. So it helped a lot in this, basically in this science of the basically the transmission.
So let's dig into the science and some of the technical aspects of our current situation. In spring 2021, as we record this, please help us understand, where is there scientific consensus regarding disease transmission in the air, where and what we need to do to mitigate that? Where are there open debates? And where are there open questions regarding our understanding of health and safety risk as it relates to SARS-CoV-2, and what we need to do to keep people safe in buildings?
Yeah, I think it's a very important question. And I think the biggest misstep of this pandemic is about the mode of transmission, and not saying up until very recently that the main mode of transmission is the airborne route. And there is a lot of scientists that basically pushed for the public health agencies to review the science and to say it like it is, and even challenged what we knew from the 1900s about how we define the mode of transmission for different respiratory diseases. And this was really important, because based on this mode of transmission, how we dealt with the pandemic and all the mishaps and abuse and missteps came. You've heard about hygiene theater. I came up with air theater, but basically even talking about masks, and not to be able to separate the supply chain from the actually if they are useful or not in protecting our healthcare workers, from the rising of the plexiglass, basically the over disinfection, the antimicrobial product, the spraying, the fogging, the ionization. All of those were from the basically not the clear guidance about what is the mode of transmission and how can we protect ourselves. So I think this is the biggest misstep. And now it's a big effort to try to fix, from optics perspective, from basically belief perspective, what are the proven basic strategies that we can adopt in our buildings to keep our occupants safe. So I think this was the biggest point of debate, and all the other mishaps followed this big point of debate. Now, as you know, like basically the CDC came and say, you don't have to over disinfect. The regular hand washing is okay. And the other thing that basically now we talk about the airborne transmission as important. But this was after a year and after like a lot of money was spent not in the right place. When it comes to school, is really important, because we have limited budgets. They were given maybe not all the money, but a big portion of the money to fix schools. And I'm very worried that we used it not in the right place.
Okay, well, let's build on that. So recently, you have been very outspoken and critical regarding the use of electronic air cleaning equipment in buildings. You published an open letter in April that did not mince words or pull any punches, and I want to read your opening paragraph. Quote, "We appeal to school district facility managers and administration leadership, as well as the relevant national and international bodies and organizations, to recognize the unproven nature of many electronic air cleaning devices. Such devices are typically electrically powered air cleaners intended to remove particles from air streams or to inactivate pathogens. As they are unproven, it is critical to avoid wasting valuable emergency COVID relief aid dollars installing them within school district facilities." You go on to put forth a very comprehensive and thoughtful review of the independent science regarding these devices. And this letter, while written by you, was signed on to by a number of some of the most foremost scientists and engineers in the world. Why did you publish this letter, and has it had the effect that you had hoped it would have?
So just a correction is that I had a co-author,
Oh, sorry.
Dr. Marcel Harman, and he did a fantastic job in drafting the letter. And as you mentioned, we have like 12 of the top academic experts that reviewed this letter and supported it. A bit of background, I have been working and reviewing electronic air cleaners products since approximately 2016. And the bulk of my involvement in ASHRAE Standard 62.1 was basically to close some of the loopholes for many different technologies, including electronic air cleaning technologies. So while it seems new, but actually I've been working for some time. And from the beginning, I started tracking school spending. In the past, we accepted that we have bad air quality in our schools. We accepted that, and we had many excuses, budget, deferred maintenance, this and that. So we accepted this. So in this pandemic, when we said, okay, we need to fix the schools, a lot of pressures from parents, from teachers, and pressure to get back kids to schools, basically, school administrators or school boards were pressured to make decisions. So I started tracking where the money is going. And to my biggest surprise, they're going to unproven technologies. Some of them are ineffective. Some of them are ineffective and harmful. Some of them are slightly effective and harmful. And some of these technology, we know that we don't want to use in our buildings from a few years back, from few scandals that happened back, and now suddenly have a short memory that they resurfaced. So I really felt like an obligation and a duty to basically, if you know something, speak something. So I felt like there's a lot of old science and new science. It's a hot topic, as you know. So I felt like we need to write a concise letter. So at least we get the conversation going. And in case a school does not know, like maybe they can read this letter and ask for the data that we ask them, and know that, you know, all the myth that some people are spreading about the basic technologies are actually myth. Ventilation works, filtration work, and we have many different models and shapes, and actually sensing the air quality is a very good idea. For example, UVGI work, and it's proven. So not only that, like I start reading the press releases of companies that ask school administrators. I wanted to know, you know, from like a social behavior, why are they using these technologies? And then I noticed that, you know, some companies will market the technologies as like a secret weapon, or soldiers. They come and come to the airstream and, you know, kill the COVID, kill viruses and bacteria, but only the bad ones. I don't know how, it's very smart. And sometimes it's a little bit romantic. They say, oh, having an ionizer or oxidizer is like walking on the beach at night with full moon, stuff like that. Like, so who can resist the 99.9% and thinking that they're doing something good, like a fancy technology and all of this? So I think, you know, schools fell victim for this marketing. And my biggest worry is that they have the money, and at the end of it, we're not going to have a good air quality in schools, and we'll be in the exact same position as we started. So the hope from the letter is to put the science out there, to disseminate it in a very concise and short way, and at least to get the school district to ask the questions.
And just since you published this in April, and we're now, as we're recording, in kind of mid to late May, what has been the reaction of the letter? What have people been reaching out to you? Has there been support or challenge of it? You know, what's the state of play 1 month after the fact?
So I wrote also the letter because many people asked to disseminate this in a concise manner that they can take it to their schools. So I forgot to say this. But basically, I think myself and the co-author, Dr. Marcel Harman, and many of the people that actually wrote it received a lot of support. Because like, it's not about us giving an opinion. It was more about, you know, this is what the science say, and perhaps we should do our due diligence. And if we don't know, we should not use unproven technologies. So I received a lot of support about it, and actually a lot of people were very courageous and very courageous to send me their own test data. So many industrial hygienists, many engineers were actually in the business of testing, and they sent me their data. So it was really nice to see that, you know, at least the discussion started and they're challenging their own school district or their own, you know, helping their clients, etc. So it has been really good. Yes.
So you're both in my last question on schools, and then also the previous question of kind of what is your sense of the science today, you know, over a year into the pandemic. I think it hits on a point that, at least in terms of, you know, our company is fundamentally a science organization, science-based organization. We deal with a lot of other scientists. And I'd say that my experience has been that many scientists and engineers feel that they have not been heard during the pandemic, that there's a lot of things happening where they've put out guidance that has not been heeded. Even today, as we begin a major reoccupancy and return to work, to school, to lots of places, people are looking at what, you know, has been referred to, what you referred to as theater, you know, misallocation of resources. Do you agree with this sentiment that we have not done a good job listening to scientists? And is that because we're not listening, or scientists and engineers, you know, possibly have not found a good way to kind of get the importance of their information off in a way that is connecting with decision makers?
So, like, one of the problems I saw and keep seeing is that, you know, the team leading the national response for COVID is a team made of doctors. And then that's great because we needed, you know, a way to treat patients, figure out all the different interventions, vaccination, etc. And that's really great. But for example, it's such an important topic, and we are getting the disease from buildings indoors. So we didn't see people sitting on these national responses that deal with building science, experts in ventilation, filtration, the aerosol scientists that tell us how the virus will basically move. What is the different particle size distribution? How much do we need to get infected? And also, equally important, like the social behavioral science, or all the amazing researchers and scientists that talk about equity, for example. Like, we have not seen that the response was based on a multidisciplinary team, that I think it was much more appropriate than only having doctors to tell us that the way to do it is wash hands and socially distance. And the other thing is that, you know, as a scientist, I firmly believe in this. You know, science can inform policy and should inform policy, but it cannot dictate other important consideration, like the moral and the political nature and the impact of a few things, like, for example, an economy. And these are important factors when, you know, policy gets done, basically.
Mhm.
And the other thing is that, there is good science and also there is bad science. So, and I'm telling you this as a scientist. I mean, in 2020, from January to June, I call it J to J, we had 100,000 articles. When I read this, I felt much better because like I always had safe tabs or safe articles I couldn't read. So a lot of these articles are like opinion statements or explanation. It wasn't really like what we are accustomed to read original research that is heavily peer reviewed. We saw a lot of preprints and all of that. So it was a little bit of the Wild West in the science as well. And I think I'm going to conclude to say is, for example, the notion of the airborne, it challenged things that we adopted from the 1900s. And people are much more comfortable to follow what they are accustomed to or they believe in, and they have this textbook. So it took a little bit of a paradigm shift to come to the point where we are today.
Well, that you bring up a number of good points, just the kind of interdisciplinary or multidisciplinary nature of the risk and the response required, and we've kind of overweighted one. I mean, there's also politics, economics, various interests at play too that have certainly influenced the overall kind of what has actually happened and how things have played out. Which brings me to my next question. As you watch, currently the US began a major reopening, reoccupancy push across the country. Where are you feeling confident that we are kind of getting it right and have the right kind of plan in place? And what is giving you cause for concern where you think that we may be continuing to double down on mistakes or kind of not really learn our lessons from the past?
Yeah, so I'm sure you're familiar with the recent piece that was published by many amazing scientists about the paradigm shift. And what was really interesting is the call to have clean air as the same that we expect, the food to be safe and the water to be safe. So I think this is one thing that I'm very encouraged with, is basically we have a drive, we're investing in clean air in general. So we talk about the ventilation, filtration. There is a huge growth in the market of air purifiers, of the demand for MERV 13, the demand for sensors and continuous sensors or just one-time sensing and all of that. So that's very encouraging, especially for me being in this field of indoor air quality. Like this is a compelling event that drove the interest of indoor air quality and health. What's not very encouraging if we are doing it wrong. So if we have the concept right, that we need clean air, but the application is wrong. And I think like we have lack of regulation and clear direction. For example, from the electronic air cleaners industry, the CDC said they are unproven. The California Department of Health said, do not use ionization. The American Association of Allergy and Asthma said, do not use ionizers. It can actually further increase asthma rates. But then these companies are having, a big day, a big year, basically. And the problem is that they act innocent until proven guilty. And the burden of proof is unfortunately on the parents or on the occupants. So I initiated the campaign with few moms to collect money, imagine this, money from parents to test these devices in labs, because either their device, we knew that their test data was not representative or it was not done in an ethical manner, or sometimes they wouldn't share the data with us. So I'm really concerned is that if we end up sort of the same place, but thinking that we were doing the right thing, but we're not, especially for schools, because we have the money now and we need to put it in the right place. I always say this, like if you're putting $1 in the wrong place, you're taking it from the opportunity to do the right thing. So this is my biggest worry now.
Yeah, well, and let's just build on that for a second. So the pandemic is creating this massive window of opportunity right now. I mean, money is flowing. There's attention that has never existed before on indoor air quality. And there's also an urgency, and that is motivated by the pandemic, but we can make changes that will have a long tail, and basically, improve indoor air quality for decades to come in various buildings. that's an exciting opportunity. It also gets on the point of where does it make sense to use these funds? What is worthwhile? What isn't? You've done some really interesting work just developing a calculator, and other approaches that help people kind of run the dollars and cents of various investments that they can make and just their operating expenses, because a lot of the indoor air quality solutions have an energy implication, they have a cost implication. So do you think that we are capitalizing, and not to make you repeat what you just said, but are we taking advantage of the opportunity to basically, fix indoor air quality in schools, in buildings? Are we fully maximizing that? And is the window still open? Can we right now, with the funding that's available, kind of course correct here if we are not on the right track to really ensure that these funds are having the best impact and bang for their buck?
Yeah. So at the beginning of this pandemic, when I used to say cost, it was a taboo. And always people would say, oh, but we're talking about human health. Human health should not have a cost. This is all great, but the reality is when it comes to the person who's making a decision, the buying decision, they think about cost. And unfortunately, a lot of good products that are in the market today or good solutions, they were replaced by unproven technologies because of the cost cutting. So this is something real. The first cost, the energy implication, is something real, and it's a factor in the consideration. And we need to be smart about the strategies that we say to try to find a balance between all the different considerations to make a decision. I came up with this metric that I think it's very useful. It's called dollar per risk reduction. So I always get, if someone is buying something, how much are you getting in return? How much you're paying for and how much you're getting in return? And this is actually was helpful because a lot of people would buy a solution, but they will not know how much they're getting in return of risk reduction. And to simplify it, you might have many different ways to go. But if you put the dollar cost and the impact on the environment, so the impact on your energy, on your carbon reduction, maybe you'll be a little bit smarter in making this decision for now and for the future. Because the last thing we want is to implement a strategy and later say we cannot maintain it or defer maintenance and it cannot work. And I absolutely think there is that we can correct the course. And I absolutely think that schools, they have the last push this summer before the next fall to do the right thing by the teachers and the kids. We all want to send our kids to a school where they feel safe from the food, from the environment, from the water, but also from the air. Like we want basically our kids to be subjected to the air where they feel productive, where they don't feel sleepy, where they don't get sick and spend time at home. So it's extremely important. I mean, they have the whole generation in their hands. So the decision they make is extremely important. And I urge, if schools are watching, I urge them to take a look at the science and implement only basic and proven technologies.
Mm-hmm. Okay. Well, in your view, how is the set of health and safety considerations within buildings, which is top of mind today and will be for some time, impact sustainability? Because there are clearly some tensions between those. It's not complete diametrically opposed, but there are trade-offs that certainly are worth discussing. And specifically, I'm interested in your perspective on things like building and mechanical system design. What technologies are going to become more important and popular, and ultimately how and where capital will be spent in buildings, just kind of putting both the sustainability and the health and safety kind of view together to make a more coordinated decision.
Yeah, there's one colleague of mine, he leads by the air and energy nexus. So this is what we're dealing with. Mm-hmm. It's a very important discussion because, like I talk about this vicious cycle, we want good indoor air quality, but if we spend energy to have a better air quality, then we are increasing outdoor air pollutants, and then we'll put it back, and then a cycle. So the best of both worlds is to have indoor air quality solutions that happen not at the expense of energy, or can be justified. And for example, for this pandemic specifically, filtration was a clear winner. talking specifically for existing buildings that don't have the capacity to increase outside air, or they don't have outside air to start with, filtration was a clear winner. It's cost effective. I calculated, for a classroom, how much it takes to pay for filtration to get a specific air exchange rate. Is the most cost effective solution we have today. And also we have test data, basically based on ASHRAE standard or ISO, that are readily available. So we can know directly if we can put this filter, the pressure drop, the efficiency for different particle size, and we can do a simple calculation to get to the efficiency for COVID. You can see a very simple thing that we have at our own fingertips and we used before, and we have a place for it in the air handling unit or the unit ventilator. We can use, and we can use very effectively. So there is the market of air purifiers. I talk about the fan and a HEPA. It's, I don't know if you're leading, but basically we have a lot of growth in the market of air purifier. We know that HEPA works. We know that you need to have sufficient airflow. And finally, there is the UVGI, basically proven from a long time. We've seen an increase in the use of UVGI. And last is the sensors. There's a big push, sensors or sensing methods, to either do it one time, periodic, or continuous. So there is a big push for that. I was talking with some parents and they're saying that, for the next year, the fall, they're gonna, give their kids the pen, the paper, but also a CO2 meter, for example. So there is a big push to use sensors and continuous sensing.
Great, I love that. Yeah, I mean, there's so much to talk about on this. I think, to grossly oversimplify things, one of the big discussions right now regarding building safety is kind of outside air and MERV levels. And are you thinking about this at the level of the central air handler or within a room? One of the interesting points I think that you and I believe enVerid and others are kind of calling out is that the idea of recirculating dirty air is obviously not good and is increasing risk. But if you're recirculating but cleaning the air along the way and filtering it, then there's real benefits to that type of approach, not only from a health and safety standpoint, but also, that then goes back to the energy costs and the carbon footprint of bringing, whether a building is able to do it or not, bringing in outside air also has a tremendous kind of impact on a building. And so there's some nuances to this that I think are often lost in some of the discussions. But it's fascinating stuff. We could have a whole nother discussion about that. I just going to design partners, you explicitly focus on innovation, and kind of the core company positioning and branding is around this. What areas of innovation are you most excited about that you think will be most impactful, and why?
Yeah, so the area of innovation is about performance-based approaches. So throwing the notion one size fits all, or I can, open a book, get two numbers, slap them, and call it a day. So really, it's more about having unique strategies for specific needs. And this is really where we can bridge between the new strategies and the processes, the old strategies and the processes, and what are the needs from indoor air quality and sustainability. So it's like based on this fundamental is that, we can do better by challenging what we've done before and taking the risks on few things. Taking the risk, trying, doing measurement verification, and then correcting course and moving on and creating a program. Also, we are training a lot of individuals that fundamentally the facility engineers are trained to respond to comfort. Their bonus plan at best would be about saving energy, but it wasn't so much about indoor air quality and stuff like that. So having the feedback from the facility engineers to go back to how we design specific strategy, how we operate. So this is where the innovation is coming. So I have this concept called clean air as a service. So basically following what we breathe, where it goes, and back to what we're breathing, and seeing how can we improve this process and what we can do about it.
So related to this, just kind of asking you to look into the future over the next 5 to 10 years. what changes do you foresee in buildings, and not so much what would you like to have happen, but what do you think is going to happen? Where do you think we're going to start to see some real innovation and change within the buildings, broadly speaking?
So I think one change, it will be coming from standards. And I think we will be working very soon on a standard that address what I'm gonna call them, the one-time off events. And you know that the standards today, like standard 6.2.1, it's very clear that it doesn't deal with fires or you know, a bioterrorist attack or a pandemic. It's actually under like the rates. There is in a very small footprint, it says these ventilation rates do not apply to viruses and bacteria. Mm-hmm. So we have first a gap from standard perspective about what should we do in a pandemic, or maybe we have a pandemic mode basically. Also, should we require MERV 13 as you know, the next thing, for example? I know, for example, LEED already have MERV 13 to go after. The other thing is that regulations to have like more about the consumer products in the field of indoor air quality, which up to right now, they're kind of silent. And there is a lot of consumer be aware that need to be tackled. And then hopefully these changes from the standard and regulation will go to our buildings, and slowly we could have some accountability. So I'm not expecting that, you know, every single space is going to be healthy and good indoor air quality. But one thing I am banking on is accountability. So the ability for us to say that this space is not performing per the standard and we need to correct course. So, for example, we know many spaces now are occupied without ventilation, but you cannot occupy a building without ventilation. Like this is how much the bar low is in standard 6.2.1. To be able to obtain a certificate of occupancy, you need minimum ventilation and you need to maintain it. So whenever someone would say, we don't have the minimum ventilation, but listen, you cannot occupy the building. So we're starting from a very low bar. I think we're gonna see improvement, and the most one will be about accountability.
Mm-hmm. So as you mentioned earlier, there's just a tremendous amount of information out in the world right now. There are tens of thousands of scientific articles that have been published. There's all sorts of new products hitting the market with their supporting white papers. You know, the public health guidance is constantly changing, and it really is a overwhelming amount of information and change going on. How do you stay on top of the pulse of the market? Who do you read? Who do you speak with? Who do you really respect? Who's a viewpoint that you're constantly just hearing what they have to say to inform your own thinking and views on what's going on?
Yeah, this is a great question. So because of my involvement in ASHRAE and USGBC, so I have the access of many different amazing researchers and scientists and academics and design engineers. And each of them, they bring a very unique perspective. And it's not always, rosy and dandy. There will like heated debates all the time and all of that. And this is really how we learn and we grow, by challenging things that we think are true. And then we move on, and by basically questioning. So I have a lot of people that I follow from the multidisciplinary research, and social media had this happen, sort of much easily. So I don't want to mention names because there's a lot, but mainly people from the ASHRAE, from USGBC, and many amazing aerosol transmission scientists. And many of those were actually, they signed the open letter. So those are the people that I take what they say, and I study it, and I try to repeat it to the best of my extent, basically.
Fantastic. Well, this has been a really great discussion. I want to just give you the floor for any parting thoughts, wisdoms, anything that we didn't cover that you'd like to share.
Thank you so much for your time. So if I were to have like the last word, I would say, for all the parents that are involved in these discussions, like make sure to get involved with your kids' school district and ask them what they did about ventilation, about filtration, about air cleaning, and challenge them basically to do the right thing for kids. Because this is a push now, the money is now, and your kids will be subjected to these devices every hour of the day, every day throughout the school year. So it's very important to be, to be out there and to be part of these discussions.
Yeah, and I guess just maybe really practically, if you're a parent or you're a teacher or you're someone at the school district level making decisions, what would you point that your letter is great, but when they're saying where do we spend our money, what would you advise them practically to do as they're making those types of decisions?
Yeah, and like I have to say, ASHRAE has great guidance for schools, universities, Harvard Public School of Health. I know a lot of guidance from University of Boulder, Colorado. So there is no shortage of guideline, just to say, but some of them are a little bit complicated. Some of them are long. I would say we need to focus on the basics. So outside air and filters in the air handling unit and HEPA in the classroom. And I am aware that a lot of parents did donate from their own money to get, HEPA to the classrooms and all of that. And then if possible to install sensors as an indication and training for the teacher. So really the most cost-effective basic solutions.
Okay, very good. Well, thank you so much. We are incredibly grateful for your time, your candor, everything that you're doing. And we look forward to being in touch.
Thank you so much for having me.